Welcome everybody who's here joining us in person, as well as everybody who is online joining us as part of the Design Philadelphia Festival. My name is Rob Puglisi. I am the Director of Innovation and Design with the Innovation Group here at Jefferson, as well as the co-founder and managing director of the Health Design Lab, and I've been helping to run this program now for 7 years. It's the 7th year of JeffSolves, which is pretty incredible. First thing is I want to thank you to Design Philadelphia. We've been part of this festival for a number of years. We're really excited. Jefferson is the title sponsor once again this year for Design Philadelphia, and I'm always excited just for this event to happen every year because Philadelphia really is one of the most creative and robust design cities in the world. And if you haven't seen the exhibits at Cherry Street Pier, definitely go check them out. There's some really incredible work from our students there this year as well. And this is part of that work. Real quick, of course, there's a lot of people that go into this program. So first and foremost, I want to thank President Tukachinsky, who's here with us today. It was because of his genius idea to start this program 7 years ago that these students at Jefferson are able to get this experience, one unlike anywhere else in the world, that brings medicine and design together. And thank you for your continued support of this program and help to give this opportunity to so many people. Huge thanks to Kate Fitzpatrick. Kate Fitzpatrick is the chief nursing leader at Jefferson Health. And she really is incredible, and she was willing to take this journey with us this year to help us connect with nurse leaders from across the organization, and a couple shout outs to those particular leaders with Abington 2, Lenfest West, up in Abington, or Jefferson Hospital, Kelly Lauman, in Jefferson, New Jersey, and Stratford, the Stratford Hospital, and the 2 East Unit, Christine Warner and Carmen Duran, as well as Thomas Jefferson University Hospital 7 West Unit. The manager we worked with there was Andrew Thumb. This was really unique this year because our students got to work directly with Jefferson nurses on finding these opportunities to design and solve challenges in the clinical environment. Another huge thank you to Rose Ritz and Heather Rode, both of our innovation champions. Thank you so much for continuing to make this program awesome and bringing so much to our students. Thank you to our partners here at Delve. This is our 4th year working with this group. And special thanks to Tom Dooley, Patrick Brandon, Jeremy Ridley, and Justin Beckstein for working with us on this program. To our co-conspirators of design, Todd Corlett and Eric Schneider, we've been working with them even before Jefferson East Falls was Jefferson, and it's been an awesome road and a lot of fun to think about how we can bring these worlds together. And then, of course, a special thanks to the Health Design Lab team. Bond, who couldn't make it, he unfortunately had to be on the other side of the country today. Morgan, Mary Ellen, Kayla, and Sarah, our fellow this year, has also been helping a lot. And lastly, congratulations to our students. We have 13 amazing students, both from City Kimmel Medical College and the Industrial Design School here at Jefferson. They worked together for a lot of months to come up with these concepts. So they have 3 great teams, and you're going to see the results of their labor shortly. Now, the way this is going to work, each team is going to have 10 minutes to do their pitch, followed by a 5-minute Q&A. We're going to be taking questions from the room immediately after each presentation, and for those online, please use the Q&A button in Zoom to submit questions, and we'll be answering those as well. So without any further ado, I just wanted to bring up Tom Dooley from Delve just to offer a couple comments on behalf of Delve.
Thanks everybody for coming. Delve is very happy to host this event. This is a project that we all love to work on. I can speak, I think, safety for everybody involved. It's a great project for us as a company. It's nice to be energized. It's nice to be around students again. It's a great project, and we look forward to doing it next year. But yeah, great work by everybody. Thank you again for letting us be involved, and we look forward to next year.
Thank you. And Dr. McKinsey?
So I've been instructed to keep it short, so I'll keep it short. The nice thing about life is sometimes you see something and you never know where it might go. And it's just incredible to see what the crew here have done with Jeff Design in terms of evolving this. We've just putting the finishing touches on our strategic plan for the next 5 years. And the theme that I've distilled down is connections. This is an example of where connections go. We started with medicine plus design. That was a connection. That led us to this crazy merger between the Health Sciences University and one with nationally ranked programs in design, architecture, fashion, textiles. We've now connected to other universities in terms of feeder programs. That started with our connection to the short admission linkages to Princeton students. And then now just seeing that nursing has been brought in. That's yet another connection. And the big one for the next couple of years will be taking this global, connecting with design, engineering, medical institutions in our Jefferson Global Center countries and taking that to the next level. So anyway, without further ado, I just applaud all the students and their mentors here, and thank you to Dell for taking our students on and doing all these great things.
All right, let's do it. I'm excited to get these ideas out into the world, so we're going to be calling up our first team, and that's going to be Nurse Pod. Team Nurse Pod, come on up.
Welcome to JeffSolves Stratford team. We are extremely excited to showcase our product, NursePod. Our team was led by Dr. Morgan Hutchinson, emergency medicine physician. I'm Sam DeMatti, a second-year medical school student here at Jefferson.
And I'm Jess Dragonetti, also a second-year medical student here at Jefferson.
I'm Nate Gotcho, Thomas Jefferson University industrial design student.
Let's begin with some statistics. Nurses are leaving their field at a staggering rate. According to McKinsey & Company, in February 2022, 32% of polled nurses indicated they were strongly considering their field in the next year. Burnout and a stressful work environment have been cited as the two major contributors to nursing turnover. Unfortunately, many of us know what burnout looks like. We've seen it in our colleagues, friends, and family. Technically speaking, burnout occurs when environmental demands exceed an individual's resources. While in nurses, environmental demands are difficult to change. As a design team, we strongly believe creating a product can provide nurses with the resources to meet these challenging demands. Taking a look at industries outside of healthcare, we have seen an investment in office spaces from companies like Google. Pictured here is the office space in Playa Vista, California. George Newman, corporate communication director from Google, said the goal of the project was to create the happiest, most productive workplace in the world. This is my first time at Delve as well in person, and this is also a great workplace. Just down the road on 11th Street in Chestnut, the Jefferson Specialty Care Pavilion reflects Jefferson's mission to improve lives. The intentional design will improve the clinical environment for both the patient and the care team. While it's not possible to build hospitals from the ground up across the nation, our team was successfully able to use design thinking to create a product that provides nurses with the resource, NursePod, to meet these challenging demands.
So research studies have shown that happiness is important in getting positive output from workers. Happiness in terms of the human experience is derived from the idea that the effort an individual puts into life to achieve their outcomes and goals is meaningful and valuable. But what about happiness in the workplace? Workplace happiness encompasses the employee experience. It's based in the ability of an employee to achieve goals and fulfill their plans. However, workplace happiness is impacted by experience and operational quality of a work environment. To consider happiness, we have to also consider stress. And so often the increase in work stress is caused by the work design and workplace environment. To cite a 2019 study, it was found that important factors in the workplace environment actually include building design, age, workplace layout, as well as cleanliness and workstation setup, equipment design, and quality. A person's work environment affects their cognitive, emotional, and physical well-being. We created NursePod to engender a physical work environment for nurses that is more conducive to work.
Through our observations on 2 East at Jefferson Stratford, we know one thing to be true. Nurses complete countless tasks throughout their workday: patient vitals, medication dispensing, starting IVs, patient hygiene, documentation, family and physician communication, and bedside procedures. I'm sure the nurses in our audience today could think of 10 or maybe even 20 more things that they complete throughout their workday. Regardless of the task, we observed the nurses at Stratford using the workstation on wheels, or WOW, throughout their workflow. The WOW was originally designed after the introduction of the EMR, as nurses were able to leave the traditional central nurse station and became more mobile. A way to document effectively at the bedside was needed, the birth of the WOW.
In general, computer WOWs are improving caregiving in hospitals. But why is this? Because mobile workstations provide multiple benefits to the hospital staff that culminates in improved patient care. Staff have the tools to perform their duties, they carry out care plans more effectively and efficiently, and patients receive the quality and compassionate care they deserve. Even with their limitations, we want to acknowledge the very real value of the workstation on wheels. Touching on those limitations, during our interviews with nurses, we were told the following things. I usually just keep syringes, gauze, and tape in my pockets. I stand so much that my lower back hurts at the end of my shifts. I can't always maintain eye contact with my patients while documenting at bedside. We wrapped up observations at Jefferson Stratford and identified the following problem areas: bulkiness, physical fatigue, lack of personalization and storage. And lastly, we found that there is a desire to keep up with modern technology. We considered both the physical product and the nursing experience when defining our problem statements. Design thinking has enabled our team to recognize how the physical product influences the nursing experience. And so from this, we developed our how might we statement, which is: how might we redesign the mobile nurse station to maximize comfort, inspire personalization, and improve its functionality?
Now I'd like to introduce you to the NursePod. Features include seating options, storage, work surface, charging station, footrest, and memory adjustability. Nurses spend hours a day standing up on their feet. This leads to not only physical fatigue, lower back pain, but also long-term negative effects. Chairs are bulky, can be difficult to find quickly, and don't always fit within the layout of the hospital. Our collapsible and ergonomic chair can be deployed and stored on the pod in a matter of seconds. We designed this chair with a saddle seat top with 360 swivel capability. Saddle seats are designed to strengthen spine, relieve back and neck pain, improve mobility, reach, as well as reduce fatigue. This allows for a better patient-nurse interaction. Medical storage can be hard to come by in most hospitals. Nurses travel back and forth from medical cabinets to patient rooms with no on-cart space for medical supplies. Clinical materials can end up scattered all over the workstation. NursePod is designed with electronically hinged storage compartments that swing out with the press of a button, allowing nurses to obtain clinical supplies and personal items without moving their position. Compartments can be quickly closed, preventing patients from gaining access to its benefits. In our observations, nurses utilize cups to store material for patient care. Oftentimes, cups have to place on the work surface. On NursePod, we have designed a removable caddy that is flush with the work surface. The caddy allows for nurses to stow away small items as well as give them the ability to take it with them without having to move the entire NursePod. NursePod has a raised lip around the outside surface to prevent spills and roll-off. We have observed nurses writing notes on scrubs and arms, so we have included a whiteboard surface for quick and easy note taking. Desktop monitors block sight lines of nurses and patients. We have removed the bulky PC to keep up with the fast-changing wireless world. According to Diversity Nursing, in the next 4 years, 91% of nurses will be able to access EHR and lab diagnostic results using mobile devices. The use of mobile technologies could reduce 46% of preventable medical errors and care issues caused by the breakdown of communication. Our design allows for a more interactive experience by implementing universal wireless charging for all tablets, smartphones, and laptops. NursePod will be powered by interchangeable batteries. Other workstations on wheels need to be docked near an outlet for charging, which doesn't allow enough flexibility. With the ability to swap batteries, nurses' workflow will be unhindered. Nurses rest their foot on the base of the WOW, even though it was never designed for that. Originally, the base of the WOW was designed to house a battery pack. Our feature encourages nurses to rest their feet. Horizontal grooves provide non-slip grip, inviting the user to place their food to alleviate short-term physical fatigue. With the push of a button or a scan of a key card, the NursePod work surface will automatically adjust the user's preset height using computerized hydraulics. This prevents further nurse fatigue having never to be adjusted manually.
And so what does the current market for NursePod look like? Well, it actually looks pretty good. It's only natural that developments in technology also drive advancements in medtech. And so over the past 2 decades, we have seen a transition from paper charting to the EMR, or electronic medical record. In fact, EMRs have been the driving force for the development of the mobile workstation itself. And the market for medical workstations is expanding. This market is actually projected to reach a worth of nearly $11.5 billion within the next 7 years. This means there is a huge market for this product. And since there are problems with current WOW designs, this leaves us with a great space for innovation.
Our team has approached the broad issue of nursing burnout from a design thinking perspective. We have begun to understand how a nurse's physical environment can impact both their clinical responsibilities and personal well-being. We believe sharing this problem area with the larger community is important to encourage others to look at nursing burnout through a new angle, one that does not mutually exclude nursing clinical responsibilities from personal well-being. Next steps would include building a full-size prototype to understand how nurses interact with NursePod in real time. We hope this user feedback will lead to further ideation and improvements in our design.
We envision building a NursePod that nurses feel excited to use. NursePod is a product that fulfills essential clinical responsibilities, but also accommodates nurses' needs as people who are deserving of a workstation that is adept for their day-to-day needs and experiences on the floor. We aspire to change the landscape of the mobile workstation to adapt and meet the needs of nurses like you.
We want to just take a moment to thank everyone who has shared their time, ideas, and most importantly, passion for this project. Specifically, thank you to Christine Bardner, Nurse Manager on 2 East Jefferson Stratford, for welcoming our team and allowing us to learn from all of your staff. Thank you.
Questions. I just want to say I really love this concept because it really shows the power of space and its functionality and how so many tools in our environment weren't designed for the people who use them, right? Something you've heard from a lot of the staff you talked to is it was designed to hold a computer, right? It was designed to hold the EMR, not for the person who will be using it. So I think that's a really incredible insight that started this. So I'll start with questions in the audience.
Yeah, so that's fantastically creative. That's great. Is there anything here that's patentable? I mean, how if you're going to go in the market, how are you going to protect these great ideas that you've sort of clustered together?
Well, I think in terms of patentability, it would be the result of a combination of features that our nurse pod would include that are unique to the nurse pod that that may be attributes, but are not all encompassing the functionality of existing products. You know, I think one of the things that we were talking about doing was having the screen. What?
Yeah.
So there, we wanted to have a transparent screen that there are products like it that exist currently, but including special features like a transparent screen, an electronic screen instead of a computer that can become transparent to allow the nurse and patient interaction to be more seamless, but also to modernize the technology and make it more swift. So, Sam, do you have anything to say? I'm sorry.
And then we have time for one more question. So, Heather.
I was curious how nurses felt about the design.
So in the health design lab, we were able to build sort of just like the shape of it using, you know, some like pretty rudimentary like blocks and things like that. So I think they definitely felt like they wanted something more sleek, because oftentimes, you know, they are bringing this around the unit and they're on their feet all day. So I think they really enjoyed how any space that was really just to like transport it, getting that as small as possible, I think was the biggest feedback we got. But certainly like building a more realistic model would certainly, I think, help that question be answered, because it's really important to see like how the user, as Rob was saying, is going to really interact with this on the floor and really just outside of like the health design lab too.
Yeah, and I think lastly, overall, nurses, whenever we were collaborating with them, their overall feedback was enthusiastic in that they had a lot to contribute, and they wanted more personalization, and were excited about the possibilities of what would need to come, especially if it could facilitate their workflow.
All right. All right, round of applause for this pod. If you saw your question online, we'll ask one of the team members to come answer the question for you. And we've got our next team on deck. Please watch the wires coming up right now. Let me just do a quick transition.
Hello, we are Motivity, and we are getting patients moving. Our team is comprised of 2 medical students and 2 industrial design students who you will hear from today. We know that patient walking is important. The health benefits span many organ systems and even extend as far as experience factors like patient autonomy. Collectively, these benefits lead to sooner discharge, reduced complications, and better long-term outcomes for our patients. And conversely, not ambulating can have negative implications for patients, like risk of DVTs and patient recovery. But it's extremely challenging for patients to walk tethered to an IV pole, wearing a strange pocketless hospital gown, strange socks that have grips on the bottom, and navigating through doorways and around obstacles on their path when they're trying to get out to the hallway and ambulate, dragging other devices in tow. So when we look at the market landscape of IV poles, they're essentially all the same in form and mainly differ in terms of price point. Almost all are also universally hated, but essential for patient care. There have been mobility attachments that exist on the market today. But these attachments fail to solve the fundamental issue, which is that the IV pole simply isn't designed to move. So IV poles exist everywhere, and there are about 1 million inpatient beds nationally. So we estimate there being about 3 IV poles per patient, and we assume an average cost of $550. the total addressable market for the IV system solution would be about $1.5 billion over the replacement cycle of that IV pole. And with trends just increasing in terms of asking our patients to ambulate, this rate is only going to increase with time. And we did our research. And it turns out the form hasn't really changed much since its introduction in 1905. So when we think about the patient journey, for example, if we think about a patient who's just undergone bariatric surgery, they're asked to ambulate every 2 hours with this tangle of tubes and wires for their pumps over the course of the next 36 hours that they spend on the unit. This patient didn't have any mobility issues before surgery, but now they're not feeling quite themselves as they make their way to the bathroom or into the hallway to do some laps on the unit floor and to get those steps in. So why are we looking into this? For patients, we're bringing a system not designed for mobility to a future where patients are highly mobile in the hospital, and we are looking towards benefits that include reduced foot injuries and fewer DVTs. For nurses, we're bringing a system not designed for complex medication delivery to function as an integrated component of patient care. Additionally, our system allows for reduced caregiver injury, improved staff efficiency, and better workflow for IV management. This offering, designed with user input from specialized patient populations, like those who undergo bariatric surgery, provides an opportunity for us to enhance our market positioning as a leading center of excellence at Jefferson for specialized patient populations. And in thinking about the enterprise, this product would also improve broad sweeping KPIs, including reducing patient fall risk, length of stay, and hospital-acquired conditions. So we asked ourselves, how might we create an IV system intended for ambulation to improve patient and nursing experiences, safety, and utility? Say hello to motility.
So, with motility, we solved 3 major issues with standard IV pole. First, we modified the base so it remains stable but utilized an improved geometry to improve walking. Second, we created a handle that is natural and comfortable to hold. And third, we developed a system to stow the handle in disciplined use. So watch a patient walking with a traditional IV pole on the right, compared to a patient walking with motility on the right. Notice how the patient with traditional pole has trouble finding an area to step into without kicking the base, while motility allows the patient to walk smoothly. On traditional pole, the patient doesn't have anywhere specific to grab, but on motility, they do. Traditional IV poles have no clear orientation and don't allow much room for patients, causing them to frequently kick the base, potentially leading to foot and toe injuries. Motility has a base profile with applied directionality, helping the patient to position the system. Motility also incorporates space in the base to accommodate for the patient's gait. Standard IV poles often lack any place for a comfortable grip, forcing patients to grab the pole itself. This doesn't allow for easy maneuverability and makes it difficult for the patient to distance themselves from the base. Patients often walk with the pole on their side, which is far from ideal. Grips currently on the market are often too small to be comfortably used and still hold the patient too close to the base. Our handle has a wide grip which keeps the patient's arms and hands in a natural position and helps the patient position the pole in front of themselves. Through discussions with clinical end users, our grip is 1.2 inches in diameter for comfort. Suggestive, but not prescriptive for where hands go, much like a bicycle handlebar.
Motility accommodates to different use states and is completely height adjustable to meet patients' needs. Within the patient journey, motility is designed to help patients walk in the hallway. The system can stow to accommodate for bedside environments, and with a small turning radius, motility helps in navigating tight spaces like a hospital bathroom. Watch as the handle adjusts between 0 and 20 degrees so patients have the autonomy to adapt the motility system between different states of motion.
In cross-section, the mechanism promotes stability and includes a silicone cap that protects the moving components, enhancing its feasibility for infection control in the healthcare settings. Stability is a major factor in our design. Watch as we test the pole with a large shake while loaded with pumps and IV bags. Despite its wide variety, existing poles tend to be unstable. Though the IV bags still swing when the motility system is pushed, the base remains stable. Computationally, physics models support our findings from our prototype testing. Motivity has a lower center of mass than the existing IV pole promoting stability. And using a force diagram, we investigated the impact of a user exerting a force by pushing the motivity system through the handle grips. The physics worked. What did we find when we tested it?
So in an ongoing evaluation, we asked non-nurses to take the motility system for a test drive through doorways, through the bathrooms, tight corners of the hospital unit. The nurses used an 8-point Likert scale to provide a rating for the motility system and compared it to the standard IV pole they used day in and day out. Our survey factors were benchmarked and standardized based off a prior study that evaluated the new type of IV pole. What did we find? We found motility not only outperformed the existing IV poles used in the unit, but it also outperformed the benchmark IV pole. Where do we go from here? Building on our initial design form factor and user acceptability study, we want to fabricate steel-bodied looks-like prototypes and compensate study participants. Our goal would be to move beyond the existing prototype, demonstrate the proof of concept in an inpatient environment, and closely collaborate in a co-design approach with patients and the care team. Importantly, when we think about moving this device towards market, we believe this device will take a 510(k) exempt approach through the FDA, which will result in streamlined pre-market testing. Based on the feedback we've collected, we've already started to propose a series of additional features that further enhance Motivity's functionality on the clinical unit. Particularly, we are looking at how cable management, wheel swapping, and oxygen tanks can integrate with the Motivity system. We've also considered manufacturability, selecting materials suitable for efficient production operations in the healthcare environment. Throughout this process, the team completed nearly 100 hours of nurse and team member observation. We've worked closely to look at pain points and iterate through multiple prototypes for the base, the handle, and the connections. Collectively, we use these observations to inform Motivity, a prototype system to bring ambulation-focused design to the IV pole for the first time in over 100 years. We would like to take a moment to thank our many partners, especially the clinical teams at Abington, Jefferson Hospital, Delve, the industrial design faculty, and our amazing MedTech advisors. We're happy to answer any questions you might have.
Thank you so much, everybody. Quick comment about that. This one, I was absolutely astounded to see how little innovation there has been in the space of IV poles. It's kind of strange, right? It's like one of those things that we just accept as existing everywhere in hospitals, and have never spent enough time to stop and think like, this could be a lot better. So, all right, questions from the audience.
Yeah, this is another great one. So I think what you need, talking about additions to this, is how does it adapt to the bed, right? Because the big problem is you're getting out of your bed, then they have to move the pole onto this contraption. So really you should have one unit and then design an adapter that would go onto different types of bed, but would lock that in and make sure that the base fits under bed. So essentially minimize the amount of things that have to be transferred. The other thing is, I assume you're going to think about the material in terms of infection control and sterilization of those hand grips. And also I'm concerned about falling on, it's almost like these pointed things there. So I think one of the things you need to think about is what happens when the patient falls. And the wheels, or when the patient's getting up, have to be able to lock, right?
So those are all great points. I'm just going to try to go through them and talk about some of the development that we're doing, as well as where we plan to go. So to start with the question, with the comment about the beds, We had a lot of discussions about this and ended up thinking about backing up a little bit and thinking about 3 major motion states that patients go through. In the first motion state, the patient's just getting up from the bed. We want an IV pole to be sturdy, fixed to the bed, and mobile. So it's not a hazard that's going to just roll across the floor and enable patients to fall. We want to avoid that. So that in that state, the pole is totally flexed with the handles closer to the pole. And we can actually trigger the mechanism such that when the handle is folded, the wheels break. And that's something we've already started looking at. To address the comment on, I think, which one's the next one? Infection control. So we've talked about the materials that this consists of. And I can go back to this slide for a second. What we're thinking in terms of materials was to make everything out of cast body. And we also are thinking about what the bottom of the IV poles look like. One thing that we did in our observations was we flipped over IV poles in the hospital unit. And many of them have biofilms growing all on the bottom of the IV poles. We actually were joking around about whether we should do a study measuring the microbiome of the wheels of an IV pole. There's a lot happening there. What we were thinking was to make it a unibody where that bottom can actually be wiped down just by reaching underneath. And when it comes to infection control on the handles, we need to be very cognizant of materials. And what we plan to do is something similar to the many other healthcare devices that patients hold that can be wiped down into 2 pieces.
And the fall.
And in terms of fall risk. So when it comes to motility, we really wanted to prevent falls. First, we do that by achieving a more suitable gait for patients while walking. Unlike an IV pole, which provides no orientation for patients, here we're providing a implied directionality as to where your footsteps go. When it comes to fall risk as well, in the bathroom while a patient's getting out of bed, we can mitigate that by having the system clip into the bed, like Dr. Chichinski was suggesting. But we can also mitigate that by the groove on the front end of motility. That groove is actually measured so the bed wheels fit within the IV pole. One of the issues with strapping it directly to the bed is then patients might not be able to do it independently as they're trying to get to the bathroom. So we want something that's intuitive for nurses and also intuitive for patients as they're trying to do that.
All right, we can answer one quick question. We've got a quick one. And then we've got 3 questions online, so I'm going to ask you guys to go answer their questions on the computer afterwards. One in the back, Rob, you wanted to say it, I can repeat it for you.
Shout out for you. That the delta between the price of the cheapest IV pole and the most, the $2,000. What is that? What could possibly?
Yeah, how much do IV poles cost? Cheapest to most expensive?
Yeah, so that's a great point, and there's an enormous delta here. Part of this has to do with where these IV poles are being used. If you're saying in an outpatient infusion clinic, no one's walking around, maybe this $45 one works. If you are in a ICU and you need pumps galore, IV bags galore, and a lot of customization as to how that appears from the nurse, you end up leaning more towards that 2800 one that has all the poles in very specific locations. In terms of where motility works, we'd like to position it somewhere in the middle because we have a lot of functionality here that a normal IP system doesn't, but at the same time, we want it to be accessible for healthcare settings of a wide variety.
All right, thank you. Give it up for people. One of you guys answered a few questions that are there online. They're good ones. Thank you. Thank you to everybody who are submitting questions online. We really appreciate it.
Acclivity, a securement system for peripheral IV catheters. Hello everyone, I'm Haley and this is my team, Andy, Clark, Julia, and Ethan. We worked with the clinicians at Thomas Jefferson University Hospital, 7 West unit. Meet Eileen. Eileen is a 75-year-old retired school teacher. One day she felt some burning when she used the restroom. 3 days later, she was admitted to the hospital with sepsis. When Eileen's daughter arrived to the hospital, she was shocked to see that Eileen had blood all over her bed sheets and hospital gown. Eileen was acutely ill and in a state of mental confusion. Agitated and disoriented, she saw her IV sticking out of her arm, grabbed it, and yanked it out. Eileen's nurse had to reinsert a new IV. This time, he wrapped Eileen's arm in gold gauze in an attempt to hide the IV from her sight. Just minutes later, Eileen pulled the IV out again, and over the next 2 days, Eileen pulled out her IV 6 more times. The life-saving medications and fluids Eileen needed to treat her septic infection could only be administered intravenously. As a last resort, the clinical team decided that Eileen had to be restrained. While Eileen's mental confusion was a symptom of her infection, mental confusion can be caused by a long list of common disorders. For example, hospital-acquired delirium and dementia.
In fact, approximately 10% of all hospitalized patients are mentally confused. And as we saw with Eileen, mentally confused patients dislodge their IVs. These patients are actually the most commonly identified cause of IV dislodgement, with over 80% of clinicians citing them as a major cause of dislodgement. These dislodgements have an enormous burden as they cost between $28 to $52 for each reinsertion in between 6 and 30 minutes, which each new IV insertion, the time and cost only increase. Collectively, these dislodgements and reinsertions cost $266 million in the United States per year. Dislodgements also cause real harm to patients. With each restick, the chance of a life-threatening complication, such as a systemic infection or embolus, increase. We talk to nurses, we look at disoriented patients will pull on anything that they see on their body, especially their IVs. The way nurses solve this problem is by covering the IV site with products such as posy sleeves. However, these products fail to prevent patients from pulling out their IVs because the products themselves are so easy to remove. The failure of these products is to blame for the treatment interruptions, physical restraints, and sedations that these patients are subjected to. Clearly, a better solution is needed. Introducing Acclivity. Acclivity is a securement system that covers the IV site, decreasing the likelihood each patient will see their IV and dislodge. Acclivity is designed to resist the activity of confused patients, but be easily removable by clinicians. Yeah. And it does this in a form that looks and feels like clothing. Let's see how it's used.
Acclivity consists of 2 parts. The first is an adhesive ridge. The second is a sleeve that hides the IV. First, the adhesive ridge is applied to the skin above the elbow. The ridge prevents the sleeve from being pulled off. The sleeve has 2 layers of Velcro at either end. The sleeve is placed over the IV site with the upper cuff positioned at the proximal end of the ridge's plate. The double Velcro at the top cuff is fastened to secure the sleeve in place while leaving the cuff loose enough to protect IV and blood flow. This process is then repeated at the lower cuff. The IV site is now hidden from the patient. Nurses can still easily inspect the IV site with Acclivity on. After the IV site's inspected, the lower cuff is refastened. The double Velcro at the cuffs prevent the confused patients from undoing the sleeve securement. When a patient pulls on the sleeve, the top cuff catches on the ridge, preventing the sleeve from being pulled down. Designed to protect the IV for its entire lifespan, Acclivity gives vulnerable confused patients the care they deserve.
About the sleeve. So Acclivity sleeve is a spandex polyester blend that is both breathable and comfortable. The sleeve will cover a range of peripheral IV sites ranging from the bicep to the forearm. But unlike current products, this sleeve is designed to stay in place. When a patient tries to pull off the sleeve's top cuff catches on the ridge, keeping the sleeve over the IV site. The IV line travels from the IV insertion site underneath the sleeve and cuff, up the arm, and connects to the IV bag. The ridge allows the cuff to be loose enough that it will not obstruct contents flowing through the IV line. The IV line does not go through the ridge.
The ridge is adhered to the patient's arm with 3M adhesive that's easy to apply and ready for 5 days of wear, meaning a patient can wear the ridge for the lifespan of an IV catheter. Most importantly, the adhesive ridge is comfortable. Weighing only an ounce, its flexible design allows it to conform to the patient's arm. To secure the sleeve, we chose Velcro because it's familiar to providers and allows them to adjust the sleeve to fit the patient securely. The low-profile Velcro will prevent most confused patients who typically have limited dexterity from manipulating the straps.
We tested acclivity against rolled gauze, the most popular solution on the market. You can see here how quickly the rolled gauze is removed. Not only is our product easy to put on and harder to pull off, only acclivity meets all of the needs for both patients and clinicians. Acclivity is so effective because it was designed in close collaboration with clinical staff. Throughout the prototyping process, feedback from nurses was essential in developing and satisfying our design criteria. That process involved fabricating over 30 sleeves. We tested a different variable in each prototype, experimenting with various materials and dimensions. We made over 20 versions of the ridge to figure out optimal shape, size, and flexibility. We started by attaching the ridge to the arm with a strap, but we learned adhesive was more comfortable, more secure, and easier to apply. We also tested a number of different securement methods. Between our tests and clinician feedback, we believe the double Velcro straps will work on the majority of confused patients, but this requires further testing. Moving forward, we would like to determine the efficacy of the double Velcro system, address the need for sizing and packaging, and explore the reusability or disposability of acclivity.
It's a worthwhile endeavor because there's an enormous opportunity in this space. Extrapolating the unit 7W size and the frequency of having confused patients remove IVs, there is a minimum demand of 580,000 acclivities nationally per year. Now, while we do not know the exact efficacy of acclivity, we are confident that this product will be financially sensible for hospital systems. For example, assuming that our sleeve is effective for even just 40% of patients and costs $15 per unit, the average savings in IV insertion costs alone will be at least $33 per patient per visit. This does not include any of the savings that will come from decreased rates of infection, restraint use, and sedation. Ultimately, acclivity allows providers to bring the best care possible to a vulnerable population. For too long, disoriented patients have endured repeat needle sticks, infections, and compromised intravenous delivery. They have endured being restrained and sedated, not because they did anything wrong, but because of the lack of effective solutions. Acclivity gives providers the power to change this story. Thanks to the security, accessibility, and comfort of acclivity, patients can be treated with the dignity that all people, regardless of their mentation, deserve. Thank you for listening, and special thanks to many of you in the audience today who have helped us with this process.
All right, we have a few minutes for questions. Oh, sorry.
Another great one. So my question is around comfort. On this strap, the Velcro piece is overhanging, it's hard. So my guess is it's going to start to dig into the skin. So I think there's a lot more work that needs to happen just to make sure that, you know, whatever's touching the skin is there. And then on this piece, I assume you thought about how firmly that adhesive actually anchors to the skin, and that comfort level of this hard piece being against there, so they're sleeping.
Yeah, so we all wore the ridge and the sleeve a lot, and like I even went swimming with the ridge on and slept for a couple nights in it, and it was pretty comfortable because of how flexible it was and because it was flat and flush on the arm. I didn't really feel it when I was sleeping, but with manufacturing in the future, like our current design has like a little bit of bumps and it's like not completely smooth, you would definitely want it to be completely smooth. And then the cuff, it has the low pile Velcro. The bottom layer is a Breathe-A-Cream fabric, which is soft on the inside, so it is comfortable. So the nurses would just have to be careful if they were putting it on to not have the hard outer layer overlie the soft inner layer.
Yeah, I'm just saying that there's a recess here so that the hard piece is actually, I can't imagine it not digging into the skin.
Yeah, I also know that there are different ways of like processing of fabrics where you can get fabrics to adhere to one another with like kind of a rounded edge through materials that like can melt them together. And so that could be a possibility of something that would smooth out the rough edge.
Remember, we were founded as a school of textiles.
And we had help from the textile.
So I noticed that the nurses were able to open up the sleeve from the bottom and pull it up, right? What was preventing the patient from doing that? And they able to get it out.
Yes, so nothing actually would prevent an oriented patient from opening it themselves. But we think that with the double Velcro system, it would prevent disoriented patients from doing so. Because the Velcro is very low profile, it's very smooth, and so it's hard to even see that there's a space to pull it up.
I think you guys estimated the cost at 15. And do you imagine it being reusable or is it disposable? If you're not sure yet, that's a fine answer as well.
Yeah, so at this point, we have considered both options. And we're just not sure what the workflow for it being reusable would look like. We know that there are products at the Jefferson Hospital system that are reusable, such as compressed socks. But the calculations that we did were with the consideration that these would be single use, and we still think that it makes financial sense at this point, and that would certainly be simpler in terms of a workflow.
We have time for one more quick question before we wrap it up. Anyone? Yeah, go ahead. Wanted to say it, I'll repeat it.
Applications be stretching so that a nurse can see through it to the ID.
So have you considered the fabric that could also be translucent so you could see through it?
Yeah, so we actually have had previous prototypes using very stretchy fabric that had those properties. Our issue with that is that if the disoriented patient's pulling on the sleeve and it's very stretchy and translucent, then they can see the tubing and then they'll give like more motivation for them to try to pull on it. And so we tested the current design where you just undo the cuff to inspect the IV site, and we found that it took less than 10 seconds for nurses to undo the cuff to just inspect the IV site, so we thought it was a worthy trade-off in our.
Thank you again to Dr. Kaczynski for joining us today, for Design Philadelphia for hosting us, Adele for hosting us, and everybody, so many people who make these students' experiences fantastic. So thank you so much for joining us today, and we'll see you again next year.